Okay, let's get started here. Hello, everyone. I'm Brian Shea. I'm with the Manufacturing Engineering Software Group at Siemens, and I'm going to be your host for today's event. This is session 2 of a 6-part series on advanced robotics capabilities, and today's session is about a technology that allows you to automate robot motion planning so that you can reduce engineering time up to 80%. So I think you'll find this session interesting and potentially very valuable. Today's session is be followed by 4 more sessions. They're shown here on that highlight different advanced robotics capabilities. And these sessions are going to take place over the next several months, and you'll receive invitations to these events as they come up. So let's go to the next slide, the agenda slide there. So on the agenda today is Yuval Heller from the Siemens Manufacturing Simulation Business Unit and Tom Munger from Realtime Robotics. They're going to give us an overview of this automated robot motion planning capability. A couple of housekeeping items before we get started here is this session is being recorded, and at the end you can request a copy of the recording if you'd like. Everyone on the call is muted, so if you have a question or comment, put that in the chat window and we'll answer the questions as we're going along, and maybe at the end of the session if there's time left over. So this is a 30-minute session, and with that I'm going to turn it over to Yuval.
Thanks, Brian, for the introduction. So, as Brian said, it's a 30-minute session, and it's 30 minutes between me and my weekend. But still, I'm happy to introduce a new product that we have just released a few months ago. We have integrated the real-time robotics controller with Process Simulate, and this integration brings us a capability to use RTR motion planner and to get collision-free motion trajectories from the controller to Process Simulate. The motion instructions are streamed to Process Simulate, and the result is seen in real time while running the simulation. Also, interlocks between robots are identified and resolved on the fly by the controller. All you need to do is to send the controller the target location of a robot, for example, the well points, and you get back the motion plans. In several POCs that we run with customers, we have seen that about 70 to 80% of the engineering time it takes to design the motion and interlock for multi-robot stations can be saved with this technology. Changes are very easy to handle, as the user doesn't need to reprogram the motion each time a change occurs. The free time can be used to try different alternatives to find an optimized design and the best cycle time, providing a better engineered solution. And here I would like to hand over to Tom to describe the technology.
Yeah, thanks, Yuval. I must say, I'm jealous of you. Sounds like you're 30 minutes away from your weekend. I'm about 30 minutes away from having to shovel up my car. We're located here in Boston, and we're looking at about a foot of snow so far and no signs of slowing down. But nonetheless, I appreciate everybody for joining us here on this call. Realtime Robotics is extremely proud to introduce the real-time technology into the Siemens ecosystem. We're excited about the prospects of continuing to build upon the already tremendous traction that we've generated over the past 12 to 16 months, providing our joint customers the ability to automatically create optimized motion plans and interlocks. This eliminates many of the conventional and time-consuming offline programming processes. And of course, we're already putting this technology to the test with some of the world's largest and most innovative manufacturers. Now, our technology at its core is a motion planning accelerator that enables a simpler, more streamlined approach to the deployment of multi-robot cells. Now, we provide this game-changing technology both directly on the factory floor, as well as in the digital domain in partnership with of course, Siemens Process Simulate. Our industrial controller and accompanying software allow users to quickly program key region interest in a pre-modeled work cell and simply with the click of the mouse, create an essentially limitless amount of potential robot motions that can be utilized as needed. We also expect in the coming months to be able to offer a software version of the real-time controller, which will eliminate the need for any hardware in the engineering domain while still being utilized on the factory floor for features like automated fault recovery. Now, before Yuval gets into some of the more finer details of our partnership and how our technology works, I want to make sure we all understand sort of how the real-time controller works and is adding value across the entire spectrum of robot deployments. And we often do this by comparing our process of robot control to the old school method of giving driving directions, as you can see here on the screen. Now, robots today are programmed much like we used to give directions before we had widespread access to GPS. I'm sure we all remember trying to navigate an unfamiliar territory with one eye on the road, other eye on the MapQuest directions, which seemed to be printed in like size 10 font. It wasn't too fun. Now, the obvious shortcoming with this was very simple. If I was unfamiliar with the area and a required direction became unavailable to me, the entirety of the directions became useless. Now, thankfully, we don't do that anymore, of course. Now we plug in our desired destination, and the GPS will not only triangulate our current location, but will also quickly provide an optimal route to get to our desired destination, even taking into account some user-defined parameters like avoid tolls or avoid all highways. We even get live traffic updates and can quickly make route changes to avoid things like traffic. A pretty unique feature. The real-time technology provides robot programmers with essentially exactly the same functionality. We're really bringing motion planning into the modern age, as you can see on the screen. Programmers simply need to load their cell data into our intuitive software, define all your key parameters and required destinations, and in turn, we will create optimal motion plans to ensure collision-free operation. In complex multi-robot cells, where robots often closely resemble the cars in the previous analogy, real-time provides optimized motions while also serving as the conductor amongst a large network of robots, producing a tightly orchestrated cell that not only improves cycle time, but also, perhaps more importantly, drastically decreases the time it takes to deploy these robots and to do this programming by up to 80%. So with that, I'll pass it back to Yuval to discuss some of the case studies and user examples that we've generated for you guys today. Thanks.
Thanks, Tom. So what we did is to integrate between the RTR controller, the real-time controller, and process simulate. And from the controller point of view, it doesn't matter if it streams the motions to a real robot or to a virtual robot. And we can utilize that to simulate and validate the motion plans. We use a process simulate digital twin and sync between it and RTR to create the robot roadmaps. Once this step is completed in process simulate, we assign the target location to each one of the robots. Once they are set, we can automatically sync them to the controller, and then we can simulate the motion of the robot as they are computed and streamed to process simulate. We can then validate the collision-free motion and measure the cycle time. So we use a process simulate as a digital twin. We sync the information to the controller, create the roadmaps, and then simulate. And you can see that in this movie. So what you can see now that I will simulate the robot, and while it's run the simulation with no motion planning, the robot will just go ahead and do its sequence while colliding with the parts and fixtures. Now I will connect to RTR controller, and you will see that the data is synchronized between process simulate and RTR. So now when I will start the simulation, the motion instructions are streamed from RTR to process simulate. And you can see now that the robot does its sequence without collision. This is on-the-fly automatic motion planning, no manual work. I just need to send RTR the target location, and the robot trajectory is calculated automatically by the controller based on the pre-computed roadmap. So we have seen that it's very easy to get collision-free motions for the robot. Once the roadmaps are ready, it is a matter of just playing the simulation without any additional touch-ups. Typically, there is more than just one robot in a station, and we need to make sure they are deconflicted. Realtime Robotics pre-compute a sweep volume for each robot motion segment and use it to automatically deconflict the robot. You can see in the illustration below the motion that the blue robot needs to perform. To each motion segment, you can see the space it will occupy. And this sweep volume is then used as an obstacle to the other robots, and the controller looks for an alternate motion for them or automatically creates an interlock until the space is cleared. So now I will run the 4 robots together, and as you can see, with no planning and interlocking, they will simply go ahead, collide with each other, with the fixtures and with the parts. To solve that, I will connect to the controller. This time I will connect all 4 robots. So now, when the connection is made, I can play the simulation and see how Realtime sends the motion instructions to all 4 robots and automatically create interlocks between them when needed in order to deconflict the robots. So in addition to the motion planning, you have seen that the interlocks are easily resolved by the controller with no additional effort from the user. Finally, with the capabilities which were demonstrated so far, automation, motion planning, and interlock, we can understand how easy it is to handle changes. Today, each change or each alternative that you want to evaluate will require you to reprogram the robots and reconsider the required interlocks, and that of course takes time. With the integrated technology, all you have to do once a change arrives, it is simply to send the new target, the new well points or the updated target to the controller and get back the modified motions and interlock. No manual reprogramming is done. It is also easy to try out many alternatives to achieve an optimized cycle time, since again, it's just a matter of sending the targets locations to the controller and get back the motion plans and interlocks. So let's see how it works. In process simulate again, I will just resequence the well points and send them as new targets to the controller. Once I've done with the changes, I can simply play the simulation and see how RTR resolves the new required motion and interlock. And again, this is done in real time without any human intervention. Here you can see how it goes in the controller. You can see the volumes that the robot occupies while doing the motion. And these are used to create the automatic interlocks between the robots. As a result of this technology, we have seen a reduction of between 70 to 80% of the engineering time it takes to initially program the robot. We estimate that even more time can be saved when addressing changes. So to summarize, you use your study information that you have in Process Simulate in order to create the roadmap with real-time motion planner. Once you have those, programming the robot is done automatically. Determine the target location and the sequence, send this information to the controller, sit back, look at the simulation results. Changes are easy to address, alternatives are easy to evaluate, and a lot of engineering time is saved. I also want to take this opportunity and describe the case study that we made with Valiant TMS in Austria. We took a framing station with 7 robots, 60 well points, complex design, very tight space between the robots. TMS told us that it takes them on average about 90 hours to program the robots. We were able to do that in 15, and that including all the setup time it requires to create the robot roadmaps. And that is about 80% reduction of the motion planning time it typically takes. So you can see that I play the simulation this time without connecting to the controller. And again, all robots will simply go ahead and do their sequence, and you can see many collisions between the robots and the fixture, many collisions between the robots and themselves. Since again, there is no motion planning at this point. The next step is to connect all the robots, 7 robots in this case, to the controller. Once I have the connection, I can play the simulation and get back the trajectories. This time you can see that the robot can do their sequence without any collisions. Where needed, there is an automatic interlocks on the fly. And you can imagine how simple the programming task becomes. And I will let you read the quote that we got from TMS, which testify about the value this solution brings. So Brian, do you want to take over to wrap up and get some questions?
Yes. And we do have some questions coming in here. Yeah. Let's go to the questions here. A couple of questions coming in, and actually, Yuval, I think this question is for you. Is the capability that we're looking at today, is that something that's available today, or are we talking about futures with this capability?
No, these capabilities are available today. We released this technology in Technomatic 16 about 6 months ago. So this is available for use.
Okay. some other questions here. Here's one. I think this was a question for Tom here. Assuming, let's say I have a process simulate already, what's the RTR components that I need to use this capability?
Yeah, thanks, Brian. So today, as it currently stands, customers will purchase from Realtime Robotics the hardware, which is the real-time controller. And that comes included with, of course, the hardware component, as well as all of the software required on our portion of the process. There's a second component, of course, that is managed by Siemens, which is the plug-in connector that enables the real-time controller and all of our technology to stream motions directly into Process Simulate for all the functionality that we just discussed. So commercially, we work through two different avenues, but of course, we work very collaboratively together, both groups, Realtime Robotics and Siemens.
Okay. And then, and Tom, I think this one's back to you again, is how many robots can connect to an RTR controller?
Yeah, so in simulation, and this is relatively dependent on the complexity of the task, but a rule of thumb or a kind of operating premise is 16 robots in simulation per real-time controller.
Okay. Oh, let's see, Yuval, I think we're back to you on this one. So what version of Process Simulate do we need to be at in order to use the real-time capability?
So as I said, the first release was with the Technomatics 16. We are aware that we have customers using Technomatics 15.1. So there is a possibility to backport this functionality, again, according to the customer and if he wants to purchase licenses. For a POC, you can use Technomatics 16, 16.01, or 16.02, which will be released in a few days.
Okay. What did you say about 16.0.2?
No, I was saying that for if a customer wants to run a POC, I would recommend to use 16.1, 01 or 02. 16.02 will be released in few days. If a customer is still using 15.1, there is a possibility for a backport of the technology.
Okay. Well, here's a good one. Do you offer training on the software? How do people get up to speed with using it? I don't know if that's a Yuval or if that's a Tom question.
So
Yeah, I'm happy to take a stab at it. So Realtime offers comprehensive training throughout our network of applications folks to ensure first that the customer is an expert at working in the real-time ecosystem, which we call our Rapid Plan software. This is the bulk of the effort, assuming that the customer is already familiar, of course, with Process Simulate. And we've developed a variety of comprehensive training packages depending on level of complexity required and bandwidth to ensure that end users are able to get working right away with the technology.
Okay. Okay. Here's a good one. Are there different sizes of this RTR capability? What if you have a robot cell with like 2 robots or 6 robots? Is the solution different?
no, the solution is the same. As Tom said, in simulation we can support up to 16 robots. So it doesn't matter if you have 1 up to 16. It's the same solution, same configuration.
So up to 16. And that's another question. Is there a limit to the number of, maximum number of robots in the cell?
So again, if you use 1 controller, the maximum is 16 robots. If you use more than 1, the maximum is up to the number of controllers you use. So if you have two controllers, you can simulate 32 robots.
Okay. Tom, what robotic brands is this compatible with?
Yeah, so Realtime has spent a good bulk of time actually and resource creating stable interfaces between our technology and essentially all of the leading robotic OEMs. So I think a safe answer is basically every major, the top 10 largest OEMs, Realtime has created a working interface between. And of course, our effort and our ability to create interfaces for smaller brands, if so required, is a pretty seamless process that we could of course discuss and undertake if needed.
Okay. And here's one. I'll throw this one out here. I'm not sure I totally understand this, but it says, what is the process if someone wants to use the software for planning their manufacturing processes?
So I can take a stab there. And we also have our global product manager, Chris Harlow, on the line, and I might ask him to add some depth. But fundamentally, real-time robotics technology adds value across the entire spectrum of robot deployments. We have products in optimization, we have products in simulation, and we have a variety of runtime features. So think of almost like a platform approach where real-time serves as sort of the cornerstone motion planning component, and it can be used as a kind of a critical planner for the deployment of robotic cells. Chris, please add some depth there if required that I may have missed.
Yeah, I didn't fully capture the spirit of the question, I guess, so I'm going to answer what I think is most appropriate here, which is there are a number of processes to deploy robot applications using these two technologies together, and the workflow is entirely dependent on your best practices and standards for how you like to deploy your robot applications. Two examples would be an application or a workflow where you use the real-time motion planner to create motion plans inside Process Simulate. You can record those motion plans to offline programs and then get recommendations on where interlocks should be created. The alternate path there is to use the real-time controller to stream motion plans into Process Simulate and then transition that entire solution, controller and the motion plans you visualized, to run physical robots on the work cell in your actual physical work cell. And then there's no need to add in any extra interlocks because the real-time controller will be managing it. But if you want more information on different ways to integrate both technologies into your robot applications, please reach out to our sales and support teams, and we'd be happy to go in depth in specific examples. Tom's contact info is just tom@rtr.ai.
Okay, well, we're down to the last couple of minutes here, so I'm gonna wrap it up at this point. That concludes our session for today, and I suspect that capability was new to most of us on the call. I hope you found that valuable. If you'd like a copy of the recording, or if you'd like a copy of the presentation material, either put that in the chat window or simply reply to the email invitation that you received for this event, and we'll get that out to you. Yuval, could you go to the next slide again, the 6 session slide? So this is a list of the upcoming sessions in the Advanced Robotic series. The next one is on January 14th after we return from the holidays. This one is about the capability to automate assembly processes that could not easily be automated in the past because they require some level of human manual dexterity that robots traditionally have not been able to duplicate. So it's kind of like today's sessions. It's another game-changing type of technology. And so I hope you can join us for that. And you'll receive an invitation for that January 14th session before that. So I think we're right about on the number here at 12:30. Thank you for joining us here at Siemens today. Have a great holiday, and we'll see you next year.
Thanks a lot. Happy holidays.
Thanks, everybody.